So in the following video, I'm going to go over how to solve a relatively complicated hybrid problem involving both significant figures and precision in multiplication, division, and addition, subtraction of various physical quantities. And by the way, this background, this is a picture of Mount Moran overlooking Oxbow Bend in the Snake River in Grand Tetons National Park. It's a really awesome place. I was there both in 2005 and in 2011. And it's over a 12,000 foot mountain, and there's a road that kind of goes back there, which meets a junction. If you turn left and go south, it takes you back to Jackson, Wyoming, and turn right and go north, it takes you into Yellowstone National Park. Really awesome place to be. I highly recommend it if you've never been. I didn't take this picture. I got this off of the internet. This is a fall picture, whereas I was there in the spring in 2005 and in the summer in 2011. Anyway, so on to this problem. So here we have a relatively reasonably nasty expression with values defined, and we're assuming that a through j are actually physical quantities. But of special note is the fact that the numbers 2 and 3 here are not physical quantities. They're part of the equation. They're exact. So let's see how this goes. So we have our givens, and we have our original equation, and now we plug the numbers in. So here's how they go. So we literally just plug them in as they are, and we start performing calculations. First, we're going to take care of the numerator here. We're going to take care of the denominator here. We're going to take care of the numerator and denominator here, all in one fell swoop. So when we do that, what we have is the following calculations, but here's what we need to keep in mind. This 19.58371, etc., is only good to 3 sig figs, because this 9.65 times 2.0294, well, 9.65 has 3, 2.0294 has 5, so the result of this multiplication problem, where you count sig figs, is only good to 3 significant figures because of the 9.65. Meanwhile, the 178 right here, which was the result of this 8.9 times 20, that's only good to 1 sig fig, because this number 20 right here only has 1 significant figure. It was rounded from somewhere between 15 and 25. If you don't believe me, plug 15 and 25 into this calculation. You'll get very different numbers than 178. So this number right here is only good to 1 significant figure. Again, multiplication division problem, you count sig figs. The number with the least, which here is 20, it has 1 sig fig. That number of significant figures, 1, is how good the answer is. So this is 178, but it's only good to 1 sig fig. We'll keep that in mind for later. Meanwhile, the 13.17 right here, this was a sum. Remember, when you're dealing with sums and differences, you're looking at decimal places, the precision, not the significant figures. This 3.77, this is good to the hundredths place. This 9.4, this is good to the tenths place. Add them together, the answer is going to be good to the tenths place, which turns out to be 3 sig figs. That's something we're going to keep both in mind, because the next thing we're about to do is a division problem. Anyway, the 4 times 24.9, that is good to 3 sig figs because of the 24.9. Remember, this 4 right here, this is a number that is part of the calculation, or it's part of the equation. So you don't count sig figs with this, but you do count them with the 24.9. This is good to 3 significant figures. So this is what we have so far. So all of these things we're going to keep in mind. In fact, if you're following along on the video, you might want to write them down so that they're there. Here I'm going to make them disappear so that I can do the rest of the calculation on the screen, but just, again, keep them in mind. So the result of this division problem, we're about to do a division problem here. This is a number with really 3 sig figs. This is only good to 3 sig figs. Keep it like this in the calculator, though. Don't round early. Never round until the very end. But 3 sig figs divided by a number with 5 sig figs. This is going to be good to 3 sig figs. This number right here, good to 3 sig figs. We'll see what 3 sig figs actually means soon in this case. And this division problem right here, it's only going to be good to 1 significant figure. Whereas this division problem is going to be good to 3 sig figs, because we have something that's good to 3 sig figs on top and 3 sig figs on the bottom. So this will be good to 3 sig figs, this will be good to 1 sig fig, this will be good to 3 sig figs. So in our next step, as we run through the calculations, we keep in mind this is good to 3 sig figs, which is the tenths place. Again, that's because we had 3 sig figs from this result right here. This number right here is only good to 3 sig figs, really because of the 9.65 from earlier. And then this 0.006, it's only good to the first significant figure, the 0.006178, only good to the first significant figure, which is the thousandths place, again because of the fact that this 178 was the result of 8.9 times 20, and the 20 only had 1 sig fig. That was a multiplication problem. This is the result of that, 1 sig fig. 1 sig fig right here means the thousandths place. And this 0.1322289, this is good to 3 significant figures, because this right here is good to the tenths place, which is 3 sig figs. The 99.6 is 3 sig figs, so this number is good to 3 sig figs. That is the thousandths place. So that's what we will keep in mind as we go to the next slide. In fact, we're going to paste it up here. So this is good to the thousandths place. This is also good to the thousandths place. This is good to the tenths place. So we run these numbers through. We have the result of this sum. Again, this is good to the tenths place, this is good to the hundredths place, so this answer right here, the 20.164987, is good to the tenths place. And then, after running through this calculation, we realize, okay, thousandths place minus something else that's good to the thousandths place, the answer is going to be good to the thousandths place, or this 6 right here. So then, as we multiply it by 3 here, which remember has infinitely many significant figures, multiply this by 2, which again also has infinitely many significant figures. So running this through, we have the 2 times this number, which is good to the tenths place, so this, which is the third sig fig, gives this number, which is good to the third sig fig, which is the tenths place. And then 3 times a number that's good to 3 sig figs, or the thousandths place, means that this number right here is good to 3 sig figs, which is the thousandths place, which means that this answer right here is also good to the thousandths. This answer right here is good to the tenths place, because we have a number that's good to the tenths plus a number that's good to the thousandths, so the final answer is good to the tenths place. So, getting rid of the commentary and bringing in our final answer, we round to the tenths place, and you get 40.7. So that's our example of a relatively difficult hybrid significant figures problem, where you have to keep in mind both significant figures and placeholders and decimal places all the way through. Thank you.